Hey, hello guys. Today I'm going to present Reconstructing Hands in 3D with Transformers, published in CVPR 2024. The contribution of this paper is twofold. First, they provide a fully transformer-based architecture for hand mesh reconstruction, and they also provide a new dataset called 8int, a large-scale in-the-wild dataset with 2D hand key point annotations. And here, I think they are the examples probably. This is hint probably. And so first of all, a bit background about Nano, since they use Nano here in their architecture. So the Nano takes in as input pose parameters and shape parameters and defines a function that returns the mesh of hand with 178 vertices, and it additionally returns 21 joints of the hand as follows. So by changing the pose, we can change the pose of the hand, and by changing the shape parameter, we can change the shape of the hand. And coming to the architecture, it's very simple architecture. They call the architecture hammer in full hand mesh recovery model. It takes in an RGB image of a hand and outputs manual pose and shape parameters. And it also additionally estimates the camera parameters to project the 3D mesh and the joints to the image space. And this hammer uses a vision transformer. They use the large version of vision transformer called VIT8 as the backbone, followed by a transformer head that regresses the hand and camera parameters. The input RGB image is first converted to patches just like in Vision Transformer and are fed as input tokens to VIT, which returns a series of output tokens. And the transformer head is also a transformer decoder that processes a single token while attending to the VIT output tokens. Here's the simple description of the figure of the model. It just takes in the image, puts in VIT as a backbone, generates the tokens and puts in a decoder and generates the pose shape and camera parameters, estimates, and then uses manual to create the mesh. And the losses are also very simple. For the images that provide 3D ground truths, L2 losses applied for manual shape and pose parameters. This theta stands for, I think, shape, and beta is for pose, maybe vice versa. And this star is the ground truth. And this X stands for the 3D joints. They additionally perform L1 loss for predicting the 3D joints. And then additionally also to enable training with 2D annotation, since they provide a 2D key points dataset, they provide a L1 reprojection loss of the 3D joints. They project the 3D joints to 2D and perform a L1 loss between 2D ground truths, 2D key point annotations, and the 2D projected key points. And in case if only 2D key points are available in the dataset, to encourage the reconstruction of the natural hands, they use discriminators for hand shape, hand pose, and each hand joint angle separately to train this adversarial loss. And now coming to the training data, unlike the other models, they use multiple hand datasets. They use pretty much all the available hand datasets, such as Frey hand, HO3D, MTC, Inter hand, and DexYCD, etc. And which results in 2.7 million training examples. And they say that the majority of this data is collected in controlled environments, as the existing datasets do not provide in the wild datasets, and while only 5% have in the wild datasets. And then they also provide 8int and describe how they make this dataset. So this 8int in full hand interaction in the wild, it contains images from these three datasets, hands 23, Epic Kitchens, and Ego 4D. And from hands to 23, they take a subject called New Days, which contains YouTube videos of hands. And from Epic Kitchens also they take some subset called Visual, and some parts of Ego 4D datasets. And then to annotate hand key points, then they use an existing key point detection model to get rough key point location, and then they ask the workers to correct the key point locations. And also, for the first time, they have previous studies that do not have this. They annotate each key point with existing and occlusion label. The existing indicates whether the key point exists within the image frame or not, and the occlusion indicates whether the key point is occluded or not. And then in total, they annotated for around 40,000 hands, 12,000 for new days, 5,300 for Visual, and 23,000 for Ego 4D, as shown here. And here are some samples they provided from the dataset. And later they split the hand interaction dataset to training, validation, and test instead to evaluate the benchmark. Now coming to the experiments. So after training with multiple hand datasets, they compare the 3D pose accuracy on freehand and HO3D dataset. On freehand, as we can see here, in terms of MPJPE and MPVPE, we can see there's not much significant difference, as actually the Mobricon performs better than theirs. And also here, also the difference is very minor, and same goes in this F scores at 5mm and 15mm distance. And if you look at the HO3D datasets, we can see the differences a bit larger. We can see that the MPJPA is 7.7, higher than the, maybe this one is the second one, hand occlusion net. And same goes, and it's slightly better, but as this is not the contributions they made, the second experiments they made on evaluation on the HNT, the data they provided, they will show the performance of this model is far better than the other ones. So this is the 2D pose accuracy. They claim that the 2D pose accuracy is much better than previous models. If you can see here, this is probably the percentage of correct key points metric at 0.05, 0.1, 0.15 millimeter distance. And we can see that there's a huge performance improvements from previous baselines, from 13 or 16.8 to 48 or 78 or 88. This shows the generalization of this data is far better than previous dataset. This model. This is because the model uses multiple hand datasets, as well as the HINT dataset, which contains in the wild datasets, and so this is evaluation on HINT benchmark that have test datasets. And now they also do some ablation studies to find out if their model is actually good, better than previous models. So they take Frank mockup model as a baseline, and they slightly change its base design. They use a smaller backbone, less than 50, and they also use a first small data set, like a quarter of the full training data set that this hammer uses. So we can see that the performance improvement is slight and it's very similar to Frank mockup as shown here. And then when they use the last data for this model, we can see a significant jump in the accuracy from 16 to 31 and etc. And if they don't use large data and just use the large model, it reduces slightly in terms of performance. And if they use hammer model, the performance is the best, as shown here. And same goes with visible and uploaded cases as well. And if you see another ablation studies, they wanted to find out how much it affects on the model when training with HINT training dataset. So this hours star stands for when training together with HINT, and this hours stands for without. And we can see that in every benchmark, the training with HINT performs better accuracy compared to without HINT on evaluation of test data set of HINT. And here's some qualitative results they show. So we can see that theirs is always far better in terms of predicting the hand, as can be seen here. Like for example, this one, the hand is like actually like this, but this is predicted like this, but this one is like this. So yeah, I mean, I think this was expected because they use many datasets. This Frank Mockup and Mesh Graphomer uses 1 or 2 datasets for training their models. So I think this is expected that this would be better than previous one.
Is that just because they are using more dataset?
More dataset and new datasets they provide. So I couldn't find like very major contribution to this paper. Yeah, clinical side there's no contribution. Only the dataset. I mean the dataset doesn't exist, but it's also 2D. It's in 3D.
But what's the main features for the proposed dataset?
So only they say that only advantage of this dataset compared to maybe previous in the wild dataset is this occlusion.
I mean, that data sets are collected from previous.
Yeah, but they are not annotated.
Yeah,
so they annotate themselves. So this, I think, as probably this, these ones are in the wild dataset that are not annotated. Maybe partially they are annotated. This they use subset of it and annotate themselves. So that's the contribution. And unlike the previous ones, they have this occlusion label that it doesn't have in the previous datasets. So that's only advantage.
But do they use the same architecture as Metro or or are they using slightly different?
No, they just use
VIT.
they just use the VIT and put transformer head and estimate the position.
Actually, that's bit different from Metro or
it's different from them, but
they are based on.
Yeah, but in terms of the method, there's no contribution. As far as I understood, there's no contribution in terms of. But I think maybe because this model is trained on large scale data set and it can be generalized, they provide some videos that shows that it is smooth predictions when predicting on the some in the wild images. So
what's camera parameter for manual?
This comes.
Pose, shape, and camera. What's camera?
This one is just used to project this 3D joints to the joints for it. It's just estimating for it. I think, they don't even have. Maybe they use the estimations basically. It's fine. So they don't even perform the loss with cameras.
If they don't perform those, how would they estimate?
Yeah, that's also a good question.
Maybe because of the 3D joint ones, it's implicitly supervised.
HMR has the camera, but they don't have this but instead they use the 2D scale provision to improve that's not actually the exact camera, but anyways, we can transform 3D as you mentioned to the 2D space using.
Towards the end, you were saying Frank Mockup, those are not trained on many data sets, so they don't follow the same training setup for all of them.
So these ones, I think they use whatever they provided in their own papers originally, and they evaluate it on their model. I mean, this is the evaluation of that already pre-trained model on HINT. So I think it's kind of.
So they don't retrain on their own data set?
I don't think so. But this one's retrained, so they just want to check this Frank mockup, good model choice over Hammer. So they try to train on large data, meaning the Hammer dataset, and also large models, they add some more additions to this Frank mockup to see if it's working. It's,
Like in right side, it says like they trained they first just trained them in there, and then they trained on their data set.
yeah, this one.
Yeah,
This one is this Hammer model without training this hint dataset, and this thing. This is also kind of self-explanatory because, like, if I do on test a hint test dataset and I didn't train on hint training dataset, of course it's not the worst. Yeah, I'm not sure.
But today, publicized the
Yeah, not but for so far they publicize code, but data is coming soon.
easiest paper I ever seen.
Yeah, it's the easiest paper and some like Galaxy. So maybe it's because of Kanazan.
Yeah, the-